Today we are going to be making a prototype motor controller out of a Milwaukee drill. Pretty much any 12-volt drill will work. This is going to be the finished product. It will allow us to make the motor go forward or backwards, and we have speed control based on how hard or how little we push the trigger on the drill. It allows us to change the motor. So we use these really often when we're prototyping for building intakes, ball paths, anything where we need some fine control on the motor. We're just testing with a brushed motor like a 775 Pro like we have here, or a sim, mini sim, anything like that. This won't work for brushless motors, but for most of our prototypes, we have a lot of these lying around. We can put them into a planetary gearbox really fast and make something that just works for intakes, climbers, anything like that. For launchers, we'll normally build like a bigger system that allows us to control multiple motors and set a specific speed or a specific voltage so we can have it running at that speed to be able to put multiple balls through and test it. But for a lot of normal, quick applications, this is one of the fastest and easiest ways to run it, and we're going to walk through how to build one today. All right, so the first step is to get a drill. Like I said, we're using Milwaukee 12-volt. These are actually screwdrivers that I picked up off eBay used. We moved to the Milwaukee 12-volt for all of our other drills, so this just allows us to keep using those batteries. But we used Makitas in the past. You can go to Harbor Freight or something like that and get a $20 drill. Anything that's 12 volt is what we prefer. Teams have done it with higher voltage drills, and you probably could, but you're going to be running your motors at a higher voltage, which isn't always good. These will always have the motor running at a lower voltage, somewhere between 10.8 and 12 volts, which is really useful to be able to test your prototypes on, because your robot battery is always going to normally give a little bit more than that or around there. So you should be pretty consistent with what you'll see on the actual robot. I went ahead and already removed quite a few of these screws because the first part is to take this apart. But I have one more to do. We'll just unscrew this. This drill does need a Torx driver or Torx wrench. Some of them might be Allen heads or Phillips. Find the right tool for your drill. We'll also need to pull, there's a little clip in here. We'll need to pull that off. A little flathead screwdriver can normally do it. They're different on each drill. This one just kind of pops up. Let's see if we can do it on camera. This one just kind of pops up and slides off. Hopefully, there it goes. All right, so that just pops off. And then we will pull the warranty sticker off, because that kind of keeps the two halves of the drill together. But we are pulling this whole thing apart anyway. So as we do that, that'll come apart in two halves. And we can leave that off. All right, so now we should just be able to open up the first half of this, and we have the inside of the drill. We can go ahead and set the empty side off to the side for us. And we're gonna pull out the entire, basically the entire mechanical assembly of the drill we no longer need. So we don't need the motor, gearbox, clutch assembly, output. We don't need any of that. We're just going to clip the two wires going into the back of the motor, and that's what we're going to extend up to the front, because in our prototype scenario, we're basically just, instead of driving the motor that comes with the drill, we're just driving one of our FRC motors in our prototypes. So I'm going to go ahead and set this down and start wiggling this out. There it goes. I'll grab our snips or flush cutters and cut the wires right at the back of the drill motor. All right, so this whole assembly is now going off the side. We don't need this. If you wanted to, you could use this for prototypes, or if you have another drill, you can use this as spare parts. If you have a broken drill, this normally works fine. If you broke the clutch or if you broke the motor or something, you burned it up. Using a broken drill is great. You don't have to buy a new one. But these just go off to the side. And now we have our two wires in here. We have a black wire here. There's another red wire down in the back. We're going to strip those and get those connected into our lever nuts. And that is how we're going to move those connections forward so we can actually use them in the drill regularly. So a wire stripper here. I'll go ahead and strip the red wire like so, and the black wire, same deal. All right, and then we have these lever nuts, which is how we've started doing most of our electrical now. These work really well. They're toolless, so all you do is just pop them up. And we'll go ahead and put the red into the orange side for this one, just to be kind of close to convention, and we'll put black into blue. Make sure it gets all the way in there so that we can latch it down. Go ahead and do the same thing with black. Twist it so we don't get any whiskers anywhere. We're just going to slide that in. Try again. There we go. So that just slides in, and now we're connected. All right, so now we have those two latched in to our lever nut, our inline lever nut, and then this wire here will go out forward, and we'll have, for this setup, we're going to put a 2 to 3 lever nut on there, so we'll have multiple outputs. So if we ever need to control multiple motors, or if we wanted to have a different type of connector, like one of the wire ends that we're going to leave on here will have Anderson power poles. But if maybe we have a mini sim we're controlling and it just has bare wires on it, we'd be able to stick those right into this connector and drive it directly. And in between those two things, to be able to extend this out, we're also going to put a fuse. So in case we start pulling too much current, the ones we're using for this setup are just a 30 amp little mini fuse. You can get these same type of connectors pretty cheap. They sell on Amazon, eBay, anywhere like that. They're oftentimes used for like cars, adding a circuit or something in an automobile. You can get them in the bigger size, the full ATC size, like we use on the power distribution panel or the power distribution hub. And so you can put a breaker in there. They also have mini breakers. I think AndyMark sold them for a little while that fit this size too. The 30 amp should be good enough for most of our intake prototypes. But if we ever do need to upgrade, we might just swap this out for something that has the ability to put a 30 amp auto resetting breaker or something like that in there. So we're going to go ahead and cut this pretty short on this end and strip it as well. And then this side, I'm going to cut somewhere about there. And take the wire stripper and do the same thing. All right, so then this goes in the orange side here. Make sure it's twisted. We don't want any whiskers again. Make sure it can fit all the way in. Little tug test. And then this gets the orange side of this one. All right, we have an extra black wire that we cut off from some excess wire we had from an old robot. It already had Anderson power poles on it and things, but I went ahead and stripped it off. We're gonna go ahead and make it about the same size as that fused wire. So I'm gonna strip one side of it, connect it into the blue side, open up that lever. And then that's already about the right size, so we can go ahead and just strip that directly. And this into there. All right, so that's the basic setup. Inside the drill, basically just have where the battery contacts are, so we'll be able to put the battery back in there. We have our trigger assembly and the main controller board. So this is going to have some of the electronics that gives us like the voltage display on the side here. It powers like the LED light up there. It does some other things, some overcurrent protection and things inside the drill. Most of them have it. Depending on the drill you have, they'll have different features in that board. Most of the time it works fine. It also has the ability to do your forward and reverse on the trigger assembly and everything in there, so you can have the motor drive forward and backwards. or anything else we need. Okay, so we can go ahead and close this up. That's all we actually have to do on the inside. So we'll just make sure everything is fitting nicely. None of the wires got out of place, anything like that. And we should be able to just get the two clamshells together. All right, that's looking about right. Something not quite right here on the back. All right, we'll tuck that wire back in. Okay. And so then all of these screws are going to need to go back in. I'm only going to do a couple before we end this. We just want to make sure it can hold together. For testing. If something's wrong, we'll have to take it apart. So there's no reason to put a bunch of screws back in it. I'm going to go ahead and put that clip back on the bottom here. That way it'll hold the battery compartment together. I didn't strip these yet, so I'll strip the two wires coming off of these Andersons. Oop, there's actually a little bit of damage. I'm going to cut those and then I'll strip them. All right, so those come off and they get stripped. Oop, only one of them got stripped. Let's try that again. There we go. All right, so we have clean wires. These are going to go right here in the middle, black to blue, red to orange, just like we've been doing. Right in there like that. Fully in and latched. Cool. We can go ahead and take the battery out of the other one that we've already made. Slide that into here. The light turned on, so we know it's working. So we know the battery part's working. We didn't break anything when we disassembled it. I'm gonna go ahead and plug this into the drill and we can see if it works. So we have power, just like that, forward and reverse. And we have our working prototype motor controller. Now we're gonna go ahead and put all of those screws back in, but it is basically finished. Thanks everyone.